section is what we call as rationalizing denominators with binomials. If your denominator is a binomial term, okay, how would you go ahead and rationalize those denominators? Now, if you have an expression of this form where your denominator is a binomial expression as 1 plus square root of x, you have to use conjugates. Now, what do we mean by conjugates? Basically, if 1 plus square root of 2 is the denominator, then the conjugate of 1 plus square root of 2 is 1 minus square root of 2. So you can see that numbers stay the same. It's only the sign that changes. This is the same thing that we use when we remember this guy right here. Here you had a plus b, a minus b. These are basically conjugates of one another. Same thing that you have here. Okay? 1 plus. And why do we use conjugates? Because of this property here. When you multiply the conjugates together, you can break it down by using difference of squares, and you end up with a square minus b square as your product. So we're using that same concept when we're working with binomial terms in our denominator. So let's go ahead and see how we rationalize those. Okay, so it says whenever a radical expression has a sum or difference with square root radicals in the denominator. Okay, and this is important. It should be square root radicals. If you have a square root, we're talking about difference of squares. If you're square root of 2, 1 minus square root of 2, and with radicals such as the denominator, rationalize the denominator by multiplying both the numerator and denominator by the conjugate of radical as a sum or difference in the denominator. Okay, so let's go ahead and try and apply this to an example here and see how to rationalize a binomial denominator. Okay, so let's say we have something like this, square root of 27 over 2 plus square root of 3. So the conjugate of 2 plus square root of 3 is going to be 2 minus square root of 3. Okay? So we start by multiplying our expression here, both numerator and denominator, by the conjugate. Okay? So this will give you square root of 27 times 2 minus square root of 3, and the denominator will be 2 plus square root of 3 times square root of 3. Okay, go ahead and times 2 minus. Simplify that and see what you end up with. With our numerator, we'll go ahead and multiply 27 into square root of 27 into 2 and 3, square root of 3 there. Now, if you want, you can actually go ahead and simplify the square root of 27. I think it will be easier that way. So if you again look at this, square root of 27 is basically square root of 9 times 3. 9 we know is a perfect square, so and this will be 3 times square root of 3. So instead of writing it as square root of 20, it as square root of 3 times square root of 3, and then with our conjugate here. Your denominator, of course, is the same thing as applying the difference of squares. So for 2 plus square root of 3, 2 minus square root of 3, we'll go ahead and apply this idea. A square minus b square is what your product should be. So let's go ahead and square minus square root of 3 square. And let's see, that will give us 3 times 2 is 6 square root of 3 on the numerator. And then when I multiply 3 into 3 square root of 3 into this 3, and then square root of 3 squared. Denominator will be 2 square is 4. And as you can see, the square will cancel out the square root, and you're left with 3 for the other side. Alright, let's simplify the numerator now. 6, this square will cancel out this square root, and you're left with 3 times 3. And then your denominator, of course, will be a 1. And when you simplify this further, you end up with 6 square root of 3 minus 3 3s are 9, and you don't have to put that 1 anymore. And that will be your answer. So we started out over 2 plus square root of 3, and this is what you end up with when you rationalize your denominator, 6 square root of 3 minus 9. At another example here, in this example, you have radicals both in your numerator and denominator. And this will, again, you start out by multiplying with the conjugate. Again, remember, your conjugate is the same terms, just a different sign. So the conjugate for square root of 3 minus square root of 2 will be square root of 3 plus, multiply your numerator and denominator by this. And let's see what you end up with. Square root of 5 plus square root of 6. Multiply that into square root of 3, square root of 2. And this thing will be over square root of 3 minus square root of 2 and square root of 3 plus square root of 2. Now what will you do is basically FOIL the numerator. Okay, so multiply each one of these expressions. Square root of 3 will give you square root of 15 plus square root of 5 square root of 2 gives you square root of 10. And then square root of 6 times square root of 3. 6 times 3, of course, gives you 18. And the last term will be square root of 6 times square root of 2, which will be 12. Or rather, square root of 12. Denominator, again, you're multiplying conjugates, which means you apply your difference of 2 square root of 3 square minus square root of 2 square. We end up with plus, so that will be square root of a square root. Okay. Now try and see if you can simplify any of these radicals. 15 is 3 times 5, so you cannot break that down any further. Leave it as it is. 10 is 5 times 2. Again, there is no perfect square, so you leave it as it is. 18, you can write it as 9 times 2, and we know 9 is a perfect square. Similar thing will happen with 12. 12 you can write as 4 times 3, 4 being a perfect square. On your denominator, you end up with 3 minus 2 because your radical and the square canceled each other out. Square root of 15 plus square root of 10 plus 9 will come outside as 3. Square root of 2, the 2 stays back. Square root of 4 comes outside. And on the last term, 3 inside the parentheses. 3 minus 2 is 1, so instead of writing it over 1, you know it's understood, and this will be your final answer. Alright, so let's take a look at an example that has variables in them. Now in this one, you can of course see you have 4 square root of x over square root of x minus 2 square root of y. Now again, you start by multiplying with the conjugate of the denominator. So your conjugate here would be square root of x plus 2 square root of y. Multiply the numerator also. And let's see what we end up with. 4 square root of x over 4 square root of x times square root of x plus 2 square root of y. The denominator will be the product of the two conjugates. Okay. Now if you want, you can try and multiply the numerator, but I'm going to leave it as it is. I'm not going to distribute those, but definitely want to multiply the denominator. And again, that will be a difference of squares. So that should give us square root of x square minus 2 square root of y square. Okay, because your second term, it has two terms in it, so make sure you put both of those in your denominator there. And let's see what we end up with. Numerator will stay the same. Denominator, again the square, will cancel out the square root, so you're left with x. Now on the second term, you have 2 and square root of y. So the square root of y will cancel out with the square. Are distributing that squared. So you basically are distributing that exponent on the 2, that exponent on. So be careful when you're working with these. Now if 2 was inside the radical sign, then it wouldn't be a problem, but since 2 is independent, you have to make sure that you square the 2 also, and you will end up with x minus 4, and this is where the square root of y and the square cancel out, and you end up with x minus 4y in your denominator. Okay? So that gives you a good example on, if you're dealing with variables, you still follow the same idea here. Let's look at another example for rationalizing the denominator. Now in this example, you will notice that you have only one radical sign, and you have 5 plus q inside that radical, so you don't have two separate radicals, you have just one single radical term. Okay, so it's very different from what you have here. You don't have square root of x in one radical and then 2 square root of y in the other. Here everything is inside the same radical sign. So when you are denominators of this form, since you have only a single radical term, this is what we had started out with. You multiply by the whole denominator itself, that single radical term. And this will give us 3q times square root of 5 plus q. Denominator is where you square. This times this will give you the squared term. And this will simplify where the square cancels out the square root. Numerator again stays the same. Denominator will be 5 plus q. And there you go. You cannot simplify it any further. You leave it as it is. Okay, and this will be your answer.